Good evening, girls. Algorithm for linear search. This is an algorithm where we are going to find the location of an element in an array. This algorithm will be in a linear array. Here A is a linear array with n number of elements where with n number of elements. ELE is the element which location we have to find. Searching means finding the location of an element. Once again I will repeat. Here A is a linear array with n number of elements. ELE is the element whose location you have to find in the array list. Suppose if the element is not present in the array list, it should give the answer as element not found. See girls, here searching algorithm we are writing. We are not writing algorithm for get data, display data, nothing like that. That is for programming. Here we are writing only the searching algorithm. Step 1. First step. Since we don't know where the element is there at the present, we will give location is equal to -1. Here we can't give 0, location is equal to 0, since A of 0 will also have an element. Second is, we have to write a for loop for I is equal to 0 to n minus 1. n minus 1 elements are there in the array. So, we have to take all the elements which is present in the array. So, for I is equal to 0 to n minus 1. Third step, if A of I means whatever each element in the array, we are taking each element in the array and matching with the search element. If the element is found in the list, then location is equal to I. Means whichever the location I am getting, element is present, that's location we have to write. That's all for this. Then go to step 4. Go to step 4. End if end for. This step 4 is nothing but if the element is not found in the list, what should it display? That's all in the list. For fourth point, if location is equal to -1, output element not found, else output element found at the position, and then we have to write the location where it has been found in the array, comma in the array. That's all for this. Once again I will repeat. This is a linear searching is nothing but finding the location of an element in an array. Here A is the array, linear array with n number of elements. ELE is the element whose location has to be found. This algorithm finds the location of element ELE. First location is equal to -1. For I is equal to 0 to n minus 1 means whatever the elements we are having, 20, 30, 40, whichever the elements you take, all the elements have to be red ones. If we are taking each element and match it with the search element. Suppose if I give 30, search for 30, then each element is tested with 30. If it matches, if any element in the array matches, that's location. This is A of 0, A of 1, A of 2. These are the elements I am having. First 0 will be taken, matched with 30, doesn't hold good. So it goes back. Then once again it takes the next element. If the search element and the first element A of 1 matches means then that position we have to take. Location is equal to 1 it will take. If the location doesn't find means output is element is empty, element not found, else output element found at the position. This is how we are going to write the algorithm. Next algorithm is binary search. Same thing, but here we are taking in linear search we took any number of element, but here we are taking an ordered collection of element. This is an algorithm when the elements have been arranged. In arranged means sorted. We are taking here sorted number of sorted list of elements. This is an algorithm where A is a linear array which contains n number of elements. N number of elements. ELE is the element to be searched. In this algorithm, we are taking a sorted list. That means the elements have been arranged in ascending or descending order. Here we take low, low means we take low, mid and high. Low represents the first element, low is equal to first element, mid is equal to the, is nothing but the middle element in the array list, high represents the last position of the array, low represents the 0, A of 0 element, 0. High represents the last position, and then mid represents the middle element, middle position in the array. Middle means half. When if I am having 5 elements, then A of 3 will be the middle position, 0 plus 5 by 2. If we do like that, 0 plus 5 by 2, you will get 2.5. We can take it as 3. A of 3. Third element. Step 1. Step 1 here, since we have done in the classroom, so I will not give much explanation. But step 1. We have to write low is equal to 0, high is equal to the last position means n minus 1, mid location, this is also searching means finding the location of an element in the array and its position. Here we are taking an ordered collection of elements. Ordered collection means elements have been arranged in ascending or descending order. Low is equal to 0. High is equal to n minus 1. Location, we don't know -1 we will give for the search element. Location of the search element at the beginning is -1. Next step, while. See, since I am telling that I am taking an ordered collection of element, first thing is low, means the first position should be while. While we should write while first element, first position is less than high, less than or equal to high, means first thing means the we are not considering the elements, only the position. 0 is less than or equal to n-1. That's all the meaning is. While low is less than or equal to high, do the steps. Do the steps. The step 3, 4, whatever it may be, you should write do the steps. Next is I should find the middle element. Middle element, mid is equal to low plus high by 2. Low plus high by 2. If, fourth step, if element is found in the middle way, mid, A of mid. If element is found in A of mid, location is equal to mid, go to step. Go to step 6. Then end if. Step 5 will tell me that if element, if the search element is less than A of mid, then high is equal to mid -1, else low is equal to mid +1. I will step 6, if location is equal to -1, then output element not found, else element output element found at the position. All these things we should write. I will tell once again. Suppose we are having 20, 30, 40, 50. Since the elements have been arranged in ascending order, 50, 60. See, this is A of 0, this is A of 1, this is A of 2, this is A of 3, A of 4. These are the elements we are having. That's why we say that low is equal to 0. This means this position of the first element and the last position n-1. Suppose if I have 5 elements, so n-1 is 4. 0 plus 4 by 2 will be my mid. While we are considering first position, we are arranged in ascending order. That's why low is less than or equal to high. Mid is equal to low plus high by 2. Low plus high by 2 means 0 plus 4 by 2. That is equal to the second position. 0 plus 4 by 2 will be the mid. Mid is equal to this. So what will be my mid? 0 plus 4 by 2 is A of 2. A of 2's position means the 40. Element 40 will be the mid element. 2 is the position of the mid element. If the search element is 60, search element beginning only, in get data only, we should give That's why I'll take it as 60. Element 60. We have to search element 60. 0 plus 4 by 2, that is A of 2. Mid is equal to low plus high by 2, that is A of 2. If element means 60 is equal to A of mid, is 60 is equal to 40, is it correct? No, it's wrong. That's why location is equal to mid. No, it is highly impossible. Then it will check for the next step. If element is less than A of mid, I am checking given element, given search element is less than 40. If it is less than 40, searching should start from here. If it is greater than 40, the searching should be this side. This side it should start. That's why here element is less than A of mid. Then high becomes mid minus 1. Mid minus 1 means this will be high, this will be low. The element will lie in this side. That's the meaning of this statement. High is equal to mid minus 1. Else, as I told, since my search element is this side, 60, I should search here. That means beginning will be mid plus 1. Beginning, low. Low becomes mid plus 1. From here you start searching. Till where you will search, you will check each element is matching with that. When element is equal to here, mid means here low becomes mid plus 1. Again the loop will check this element is matched here. No, it's not possible. Then again it will take the next element. When it matches, the position will be given as output. Output element is found at the position get stop. In the array location we have to display and stop it. This is the algorithm for binary search. Insertion sort algorithm. This algorithm explains to sort the array element. Sorting means arranging the elements in ascending or descending order. Here A is an array containing n number of elements. This algorithm explains to sort elements in ascending order using insertion sort method. Method we are using is insertion sort. See girls, we are having different types of algorithm for sorting. We have bubble sort, selection sort, quick sort, insertion sort, etc. But here what we are using is insertion sort method. We consider for first step for I is equal to 1 to n minus 1, do the step 2 to 1. 2 to 7. In this algorithm, we consider the first element should be as a key element. Key means we think that this element has been sorted. Other elements are not in the sorted list. We consider this as a sorted element. Other elements are in the unordered list. This is sorted list and these elements are unsorted list. This is what assumption we are doing. It is not true. Now we start comparing the elements. We start comparing the first element with the next element. Since we have to take J, J is unordered list elements. J is equal to I minus 1. When I is equal to 1, J will be A of 0. When I becomes 2, J will be the previous element. This element, these elements will be the previous elements. J is equal to I minus 1. That means the previous element. Since I have to compare, as I told, I have to compare while loop we have to take key element is less than a of j. J means the previous element. When I becomes 0, then j will be the previous, means from this is the first element. That's why for I is equal to 1 I am starting, not from the 0. So from here we have to start. That's the reason j is equal to I minus 1. I from 1, I is 1. From here I am taking 1 minus 1 is the 0, a of 0. That means the previous element. While key element is less than, I am comparing this with the, if the key element is less than a of j and a of the j number j is should be less than or equal to 0. I should not be, I will not be having any element in a of minus 1. I don't have this. That's the reason what I will do is j is greater than or equal to 0. J is equal to I minus 1 I have taken. For I is equal to 1, that means the previous elements. I will not go beyond 0. That's the reason the number 0, 1, 2, 3, n number of elements, j should be greater than or equal to 0. From here only I have to start. Do the step. Do steps 5 and 6. That means when as I told how to interchange. If the key element is less than the next element, exchange. Like that we are going to exchange the elements. A of j minus 1 is equal to a of j. This is very important. J is equal to j minus 1. That's how. Means each time my unordered list will be less. Ordered list j, a of j element will start increasing. That's how the algorithm says. This is step 5. This is step 6. End of for loop, end of if loop, end of step 4, whatever it is, step 4. Then a of j plus 1 is equal to key. This will be the key element. Each time I will consider these will be the key. After sorting each element, it will take that element as the sorted key element and return. 6 j is equal to 7 and then return. Once again I will explain with the numbers. Since 55, 40, 30, 25, 60 I have. First a of 55 and 40 are compared. Since these two, 40 is less than 55, in the first step 40 will be exchanged, 50 will move this side and 30 and then 25, 60. This is how it will be arranged. Next, 30, element 30 is compared with 55 and 30. Since 30 is less than 55, it is also less than 40. So it is will take the first position. Then other elements will become like this. See girls, I am not telling in detail. In the class I have told. Now I will tell you the gist so that you should learn all the algorithms. Next, we think that these all three elements have been sorted. 25 is taken. Here you can see these unordered list elements are decreasing. Ordered list elements are increasing. 25 is compared with 30, 40, 55 and then 55. So 25 will acquire 25, 30, 40, 55, 60. So in the next step I will consider 60 where there will not be change. by n minus 1 means first 1, 2, 3, 4. Since I have taken 5 in n minus 1 pass, all the elements have been arranged. This is how we will do in insertion sort. Thank you.